Here we have a Pi 0, and plugged into the Pi 0 is an on-the-go cable, as well as a power cable. The power cable plugs into a USB battery pack, and it will now boot up. The Pi 0 is housed in a PVC tube, which is a common plumbing fitting pipe. It also has a HQ camera module and a C-mount 8mm lens, which connects the whole thing together. When we power up the device, it will look for a Wi-Fi hotspot. If it doesn't find a known Wi-Fi hotspot, it'll actually create its own, which we can connect to with our mobile phone, tablet or laptop. There we go, LetsLapse. That's the Wi-Fi hotspot that it creates, and we're now connected to it. In order to access the device, we need to open up a browser and type in the IP address. When it sets up its own IP address, it's 10.0.0.5. Accessing this IP will let you see the server that's running on the Pi 0, which interfaces with the camera. From here, we can engage the streaming directly into the browser to see what the camera is seeing based on its current position. Here we have the live feed, a minor delay, but nothing worth worrying about. So we can straighten up the camera, compose our shot, get it ready for the sequence that we want to capture. In addition to starting the stream, we can obviously stop it, but we can take a still image. In auto mode, results are patchy, and this is no fault of my own. Well, who knows, maybe it is. But this is why we have the manual controls. So there's a couple of cheesy little presets in there that don't actually do too much. But under manual control, we can change the shutter speed, the ISO, and the AWBG. We can also capture RAW, but no need for that right now. Each image gets stored in the gallery, and we can click on that to open it up, and we can zoom in to see it's pretty high quality. Under time-lapse, we have the ability to start time-lapse without any thought whatsoever, or we can choose manual control and give the shoot a name. The shoot name has to be unique, so we'll call ours Pi Demo, and there's a checkbox there called Underexposed Nights, which we can discuss more later. But clicking start will create a new project and store every picture on the Pi 0 micro SD card. Now the first 10 images this takes will refresh so we can get a good idea of the shot and the light. Each image that's captured is analysed, and if it's too dark or if it's too light, the following images will be modified to adjust for this. The same actually applies for the color temperature. So when we do transition from day to night, this can be managed as well. It refreshes for the first 10 images, and then after that, it is left to its own devices. We also have the ability to stop and finalize. This essentially means kill the project, and that means we need to give a new name for a new project when we come back in. For every image that is captured, a progress file is updated to store the settings of the previously captured image. This means that in the event of a power reset, battery change, or even a crash, which hasn't happened for some time, when it reboots, it will resume with the settings that it had previously. This is particularly useful in low light or more difficult lighting conditions. So if we unplug this battery pack, it will basically kill the device. What we're going to do is enable Wi-Fi hotspot on my phone, and this is a known network to the device. What will happen when we power up the Raspberry Pi is it will boot and it'll look for a Wi-Fi hotspot, and if it finds a known one, which it has already had configured for my Android hotspot, it'll connect to that, and rather than me connecting to the device through the Pi setting up a hotspot, my device or router, whatever it may be, will actually manage those connections. This can be quite useful if I'm setting up the device and I don't want it to emit a Wi-Fi hotspot, for example. Keep in mind that when we do set up a hotspot, we need to know the IP address of the device that's connecting to it. Once the device is connected to the hotspot, we can then see the details of the IP address. And here we have the IP of 192.168.117.202. So this IP address has been allocated to it by my hotspot sharing. So now we enter that address. It starts off with a loading screen, and now it says shooting images 34. So it's actually continued capturing images beyond what it was when we restarted the device by unplugging the power. We've got the config screen, which lets us update LetsLapse, where it does a checkout from the Git repository. If required, it'll restart the user interface, as it has right now. And now we are refreshing the shooting screen and we're up to image 43. In the gallery window, we can choose time-lapse gallery and we can see images as captured in the time-lapse gallery. This one here displays every 100 images. It doesn't display every images because it adds a fair bit of overhead on the device. It's a very low powered device, so we don't want to ask it to do too much. Now we choose stop and finalize, and it'll ask us to confirm, do we want to stop the time-lapse shoot? Yes. Choosing the stop and finalize will kill the progress file, which means that when we reboot, it will not resume the previous. Here we go, back to a live feed of the stream. That is the end of this little user interface walkthrough. Code is available on GitHub, or find out more at letslapse.com.